All right, so now let me explain this type of charging IC, okay? Because I show you the first video a different IC, that is transistor based charging IC. There are some model that you see that IC, but there are some that you see this one. So now let me show you another line that you will check in case you see this type of charging IC. We have up to 4 or 5 lines. So now these are our normal BQ IC, either BQ2 25601 or 25600 or 2568 something. Okay, any of the transistor, any of the BQIC, this is the line that you will check. Now when you have this type of charging IC, you come to this line, REGN line. You will notice that this line, you might see NC in this type of, in this capacitor. It means that this is not the type of IC they use, charging IC, it's the other one. So now this line comes out of that charging IC and also goes back to the same charging IC, but the line change to TS. It comes out of REGN and comes to this TS line. So now this is the same charging IC, REGN. It comes out of here and then it also enters back to this same of charging IC. See, this REGN. Now on TS line, now you see two type of resistor. Down, this resistor creates a divided circuit. We say that when one resistor is connected to in series, is connected in series, now the other resistor is connected to that same line, but one is grounded. Therefore we have a divided circuit. Now you see NC in this resistor. It just means that they don't use this type of charging IC. That's why you are seeing NC. They are using that transistor, the one I showed you first. So now I'm using this one to explain in case they use this one, or you see, or you are working on a model that they are using this one. So now you see this two resistor, there's a divided circuit, and you will, this resistor, the value of it is 10k 10k each. And there's a law of divided circuit that when R1 and R2 have the same value, that the input voltage will be divided by 2. And the input voltage is 5 volts. That REGN send out 5 volts, and when it comes to this line, it divides it into 2. That is 5 volt divided by 2, that will be 2.5. So now this first resistor, R2218, you get, on one side you get 5 volts, on the other side you get 2.5. If you don't have 2.5 on this other side, that means that this resistor, anyone check on the value of that resistor. If it is not 10k, or if the value has changed, you check, you cross check with the diagram and replace 10k on each side. It's going to work, because this voltage must divide from 5 volt to 2.5 volt. So this is the next line that you will check. If your phone is having any of the errors, maybe yes, it's having any of those errors, you have to check on this line also, TS line. Okay, let me show us another line. You see this bad sense in the other IC. We saw bad sense and iSense. So in this type of IC, you see bad sense inside, then iSense outside. It still goes back to that iSense that we explained. Okay, it still comes back, enters our power IC on that charging section, iSense. So that iSense, you check it, it should be, it should have connection. If this iSense is open, it's going to have fault. So now this iSense also comes out of this battery connector. So let's go back to the other IC. Okay, now this, I've explained two lines on this type of charging IC. Please don't stress yourself. If you have those faults, go check these lines one after the other. They say there is a 90% guarantee that one line is faulty. Okay, it's called troubleshooting. Now let me show you another line that you will check. Please note this line. Even if you have to write them down, just write them down. Now there is also a sensing resistor on our crystal. That crystal oscillator, there is also a sensing line. I'm going to show us. Now If that line, there's also a divided circuit. If your crystal is faulty, it will have cause your phone to have those errors. So now let me, this is not the section. This is not the section. Okay, so now I will go down. If you come down, you see this section. This is the section auxiliary ADC. That's auxiliary analog to digital converter. Now this is our crystal DCXO. This is our crystal. Now this circuit, I will explain how this circuit works. Okay, so now this is our crystal. One side will give you ground. Okay, the first one will give you value, and that is 700. If you use some meter to check, the first pin 700. Then the second pin is grounded. The third pin will give you okay, the first pin will give you 400. The second pin is grounded. The third pin will give you 700. Then the fourth pin will give you 400. Okay, now let me show you. Let me bring our diagram, that the one we combined, so that I will show you how to test it. Okay, this is our crystal. This is number one. You see the value in respect to the kind of meter that you are using. This is the value. When you click on this, you test this, you have to get 300 to 400 volts, sorry, ground readings. That is your value that you will get. So now this is the line. If you are tracing it on our schematics, this number, the first pin. Now the second pin is grounded. This second pin is grounded. So if it is not connected, if you don't get beep sound on this on the second line, you just have to jump out this line to ground. Okay, because there is a sensing resistor inside this crystal. So now let me explain how this line works. Now you get 1.8 volts from our power IC. Okay, you get 1.8 volts from our power IC. Now this number one, this 1.8 volts, there is a resistor that is connected on this line, 0 ohms resistor. If this resistor is missing, this is the resistor I'm talking of. If this resistor is missing, that 1.8 volt will not be able to enter your crystal to divide it. So you have to check this resistor. If it is missing, you have to breach it, jumper it. It's 0 ohm, so you have to jumper it, breach it together. So now you must get 1.8 volts. If you don't have 1.8 volts, find 1.8 volts and jumper to this line. Okay, so now this other line, there's a capacitor connected from that line to this line. This line is ground. Don't confuse yourself. This line is ground. If you follow this line, you know that, notice that this line connects to our crystal on pin number 2. Look at it. This pin number 2 is ground. So they connect that line to this pin number 2. So it is grounded. Follow this line. It is grounded. So those capacitors are connected in parallel. One side to the normal line and the other side to ground. So you also see this line, there's a capacitor here. One side is grounded, this other capacitor is also grounded. So this line is ground. Okay, so now let's follow this 1.8 volts line. This is the resistor, 0 ohms resistor. Please check this resistor. It should give you 1.8 volts on both sides. If one side is giving you 1.8 volts, you can remove this resistor and jumper it. Just bridge the 2 dots, and then test it again. You will get 1.8 volts on this resistor. So now you have to follow this second side. You have to follow this line also, because this line comes and then there's another resistor on this line that is 100k. Okay, 100k. So now this resistor, we have our resistor inside our crystal that is connected to ground. This is our R1. This 100k is our R1. Okay, the other resistor, that 0 ohm resistor, is not our R1. It's just connected. They just connect it. So this is our R1. This other one I'm talking about, this is our R1, 100k. If the value of this resistor is missing or is faulty, it's not giving the accurate value, that your phone will have issue. All those errors that I listed, you will encounter, you will see those errors if this 100k is missing or is not giving you the accurate value 100k. So this 100k is our R1. Now our R2 is inside our crystal. You will not see this inside our crystal. Okay, so now there's going to be a divided circuit on that line. When you check on this side of the resistor, this is the 0 ohm resistor. The second resistor is our R1, which is our 100k resistor. So now this 100k resistor, you will get one side, you will get 1.8 volts. Then the other side, you should get, let's say, 0.6 to 0.9 volts. Okay, it should divide, because inside this crystal, there is a divided circuit at work inside this crystal. That is a resistor, a sense resistor. Let's call it NTC resistor inside. So now one side of the resistor is connected to ground, which is pin number 2, and the other side is connected to this pin number 4. So now when it comes out of this pin number 4, it connects with this 100k resistor, and then there is a divided circuit. Now this side of the line is our output line. It will send out that divided voltage into that power IC. Okay, let me explain again. This 100k resistor, 1.8 volts will come and meet this 100k resistor on one side. Now this other side is connected with another resistor inside this thermistor, inside this crystal. Now one side of the resistor inside this crystal is connected to pin number 2, which is ground, and the other side is connected to this other line. And when it comes out, this is our input line, this is our output line. It will come out and connect back into your power IC. So this line, this 100k, one side should get 1.8 volts, the other side should be divided like 0.6 volts.